Hello, everyone. Our next speaker is Mr. Bob Sharon. He's the founder and CEO of Blue IoT. Today, he'll be talking about smart buildings and smart cities. So, over to you, Bob.
Thank you very much for that and for this time. Hello, everybody. At the conclusion of this, you're welcome to ask me questions. So I'll try to keep it as concise as possible. And if you bear with me, I'll just go through about 2 minutes on just as a background on what we do, but that will be a very fast process. Then we'll go into the fun in going to smart cities. Blue IoT, we established about 4 years ago, basically to leverage the Internet of Things as an enabler to support the blue economy. That is, for us, smart buildings, smart cities, and smart assets. So we, in fact, developed the first IoT-based, cloud-based EMS, BMS, building management system to automate buildings from the cloud. And we won some awards, the Facilities Management Association last November, the IoT Pioneer Award last June. And the system we developed is called Encompass Blue because we encompass people and buildings. And basically we do energy management, building automation, and predictive maintenance, fault detection and diagnostics, and health, wellness, safety. That's enough of Blue IoT. Now let's get into the fun of smart cities and smart buildings, and then we can have a fun Q&A at the end of this, so don't hold back on your curly questions. So here are some stats on the market that is being forecast, and they vary, between I've seen figures of 1.5 to $2.5 trillion come 5 years from now within the space. And the figures we have here are from Grandview Research. So we are talking about quite an increase year on year. Personally, I think it'll probably even grow more. It is increasing year on year. I think the increase will actually be higher personally, but that's my own personal view. It's growing at a rate of knots now. It's really taking hold, and to be honest, I think COVID-19 will accelerate this. COVID-19, the problems that have come up as a result, lack of digital transformation in buildings. So building managers couldn't get back to the buildings. They couldn't see what's going on. How do we manage the building remotely? How can we understand what's happening in the building? Most buildings don't have that much data, to be honest. The old BMSs don't have a lot of information. So what's going to happen now is we need to accelerate the digital transformation in smart buildings at a much faster rate, not only from a COVID safe or smart city perspective, but purely based on cost. Operating costs. So I would ask people and say, can you afford not to do this now? And we'll go into a case study later on, and I'll give some examples of what can be achieved when we go down the path of digital transformation in smart buildings and cities. So, it's quite an interesting topic. So I guess the first question we ask is, what is big data for smart buildings? What are smart buildings? So I've got a definition. There's a number of different definitions around smart buildings, and there's a few different things where it could be smart management, smart automation with AI, machine learning, and let's throw in what I call four-dimensional digital twins, not just digital twins. There's a lot of market hype, so people are mentioning two words that I'm hearing mostly at the moment: AI and digital twins, and everyone's jumping. So we use AI, we've got digital twins. Well, in most cases, the question you need to ask is, the AI that you're using within the built environment or smart buildings or cities, is that self-actualizing? True AI makes decisions on itself and will implement and do something by itself. It's not just an algorithm. Machine learning uses algorithms. It's a subset of AI, and there is a lot more of that around. But the questions need to be delved into. Same with digital twins. Some people think, wow, digital twins. Well, digital twins basically is a building information management view, right? It's a three-dimensional CAD drawing, might come out of Revit or whatever. I've got my 3D CAD drawing of the building. I've got my digital image, my 3D digital image of the building. Great. What's it going to do for me? Well, yeah, okay, I can see it, but how's that going to return to my bottom line? How's that going to save me money? How's it going to make my building safer? How's it going to make it a better place to live, to work, and operate? Now that's an interesting question. So just because somebody has a digital twin by itself means nothing. It's what you do with the digital twin that is important. What you do with AI. So what outcomes are they going to deliver? Not just, we got it, right? You know, somebody came to you and said, I've got IoT to sell you. Well, what does that mean? I've got IoT, so what? What's it going to do for me, for you? What is it going to return to your bottom line? How is it going to make a difference? What's it going to do in answering your problems and pain points? They're the questions that need to be asked in any smart building or smart cities project. And so what we have is a system or systems, and it'll also consist of many applications. I mean, and we only do one part of the jigsaw puzzle. So you've got things like asset management, you've got work order management, you've got FM management, you've got so many different aspects, and then huge data lakes covering multiple buildings and cities. It might be urban development and planning, all sorts of things. And then, of course, the building controls and the management of the buildings and the lighting and the HVAC and all the water and hydraulics and all the different systems. And you keep going down. And then the health and wellness and safety and COVID-19. What are we doing around that? Safety, distancing, numbers of people, antimicrobial sprays, whatever, airflow management, so many different things. What are we doing? So there's a whole lot of things. So we need to be picking up the data. So in terms of getting the big data and the analytics, if we haven't got data or enough data, well, we can't manage what we don't know. So we need to be collecting lots of data. So what is big data? And here's a number of questions we need to ask. Well, how big is it? Well, the good news is when we're talking about managing buildings, and if we're doing it perhaps in a more cyber secure manner, preferably using a non-IP network in the process, and using low power wide area networks, meaning the sensors take very little battery. And that means they can last several years on a battery before we change it. We don't have to run power cables to them, which is why we run low power wide area networks. And again, using those in many cases means non-IP network, lower cyber security risk. This is a very good thing. So if we can then reduce the volume of data that comes through, but we could have 10,000 sensors, but each producing a little bit of data, not a problem. And then we've got, the velocity of data. So how fast are we picking this up? How quick do we need it? What sort of latency have we got? And then we've got the types of data. Put it this way, you're not going to be sending up video surveillance files over LoRaWAN or Sigfox, put it that way, right? That'd be a bit of a problem. You'd be doing that over, over Ethernet, over fiber, whatever the case may be, but you need lots of bandwidth for that. So courses for courses, depending what you want to do. Then we got the veracity, which is the quality of the data. Now, if it's all set up in the correct manner in the first place, then all the data you're going to have is going to be relevant, and you're not going to have to clean it up. But if you've got old legacy systems, oh gee, then that's a separate story, big problem. If you're trying to dig up historical data and clean it up, and you need to, again, that presents its own challenges, but it can be done. So basically, we need to segment this, and we need to organize our data. So big data management. Now, how are we getting it? Structured, unstructured? What are we doing with it? and how can we continually improve process. If we design it from the beginning, so if we're going to take over a building or a campus of buildings and places, and public areas perhaps as well, like railway stations, airports and so forth. If we design a new system, then we can structure everything correctly, and that way we can have an ongoing, continuous, structured set of data the way we want it, organised the way we want it, cleansed from day one, from the beginning, all set up. So that would be ideal, but you know, that doesn't always happen that way. So sometimes we have to work with all kinds of data, especially historical stuff that we're trying to compile, analyse, and put into the system, and move forward from that. I like this slide. This talks about the architecture, the 4-stage IoT architecture here. And so we start at the edge. And what's at the edge? Well, we got sensors, we've got actuators, we've got controls. Then we've got the gateways. So if, for example, we're running a non-IP network, we'll be running radio gateways, whether you're running NB-IoT, well, NB-IoT, you won't need a gateway for that. But if you're running LoRaWAN, for example, which is one of the more popular IoT protocols, you'll be running a number of gateways in a building. If you want redundancy, you'll have several gateways for failover. Then you'll have your, well, in stage 3, you've got edge analytics. Now, that could be within the controllers, for example. It might even be in some of the sensors that transmit data every so often, but stores the data. Or it just may be literally in the cloud itself. Some of it may reside in the gateway as well. So there's many ways to skin the cat. There's no right way or wrong way. It depends on the use case. So we need to understand, what is the use case? What are we trying to achieve, so we can architect the best method forward in terms of the architecture that we want to apply. And of course, we've got, you know, a very critical component, and that is the edge, the data center, the cloud. Where does the cloud sit? Now, if we're dealing with government bodies, what about data sovereignty? We need to look at issues of that. Patriot Act, all sorts of things. If we're not dealing with government bodies, not such an issue there. But what about the quality of the data center? What about the uptime? You know, are they tier 3 or tier 4 rated? What's the security around the data center? What about the pipes in terms of the comps going into the data center? How reliable are they? All very important questions to be asked. There's a whole lot of things. Then, of course, around all of that, we've got the whole cybersecurity aspect of it. What are we doing around cybersecurity? Not just at the edge, but all the way through from end to end. How are we mitigating risk around all of this? You know, how are we handling the analytics? How are we handling the various components? And then what if we're, you know, using open systems? And hopefully we are using open systems, because if we are, that means we can collaborate with other platforms and send and receive data and exchange data. So how does that all work together? How's the security around that? And so forth. So a lot of people make a big deal about IoT and try to define it in the most complicated way. The way I like to define it is very simple. It's a bunch of stuff connected to each other, whether it's phones, whether it's stoves that run off the internet, or fridges, or a car, a Tesla that picks up data from the cloud, and certainly the self-driving cars do, all sorts of things. So stuff connected to each other. Now, technically, it can also mean stuff wired to each other as well. And, you know, I've heard of stories and organizations talk about IoT controllers, but yet it's got a hardwired Ethernet connector. Now, technically it is IoT, but in reality, practically speaking, well, yeah, I might question that, but that's a discussion to be argued over at another point in time. So what are some of the individual components of all of this? So here we have something around movable objects, asset tracking, geo-visualization, fencing, coding, and then analytics on moving assets. We've got building management control, might be either end of these moving assets and warehouses, factories, whatever the case may be. And then we're streaming data both at site, but also from trucks, buses, planes, whatever, ships. So there's all sorts of architectures that can be applied, and then therefore the protocols. How do we compute? How do we analyze if we're on a ship? I don't think we're going to be exchanging data to the cloud too often. So obviously we need to have something that's working within the ship to operate, maintain, monitor, do whatever it does, and then it might send data when it gets to shore or when it's in range of a city, rather than hitting the satellites all the time. Number of options with this. So again, there's many ways to skin the cat, and there's no cookie cutter approach. It really depends on the use case as to how we put it together. Again, with sensors, there's heaps of them. The most common one would, of course, be temperature, humidity. That would be the one that would be used most commonly. But we've got there's all sorts of things. Then you go into water leak detection, vibration for motors. You've got CO sensors, CO2 sensors. You've got lux level sensors for light, noise sensors, dust particulates, air quality, VOCs, all sorts of things. Pressure differential for pumps and for filters, weather stations. We even have the sensors we can get from the US that detect golden stat and biosecurity threats. There's all sorts of things that we can get. So for example, we manufacture some, others we use third party, kind of depends at the end of the day what we're looking for. But there's so many different sensors that we can get. We can virtually measure almost anything, and the costs have gone down dramatically from where they once were. Once upon a time, you'd spend thousands and thousands of dollars to measure one thing. Now, that's changed, and IoT has brought about this revolution in all of this. And here's an interesting example of a solution set for transport and infrastructure. So you can see what we might use for rail, road, ports, and infrastructure, and how we might, the things that we might use in terms of maintenance, predictive maintenance, and security. There's all the different elements that goes into each of these. And again, systems are designed specifically to meet the individual use cases. But right now, more and more IoT is going in. Up to a couple of years ago, it was mostly academic, a few little proof of concepts. But really, in the last 12 months, things are moving along and it's accelerating at a rate of knots. And it's going to be a lot of fun in this space. Mind you, beware, buyer beware, there's a lot of smoke and mirrors in the industry where people say they can do a whole lot of stuff. Bit of due diligence to sort out what is real and what is not. I highly recommend with any organisation, and including us, ask us all the hard questions. Very important. Okay, objectives. Now, at the end of the day, people might want to sell this great widget. Look, I've got this great IoT thing. I've got this great sensor. I've got this great widget. It's really good, this edge computer. You're going to have one. You know, we can measure stuff on the edge. This is so good. Yeah, but why is it so good? What's it going to do for me? Okay, well, okay, I can get some you know, pressure differential. I can measure power. Yeah, well, why? So what's that? How's that going to help me? What's the business case? What's the use case? For what reason? What is the outcome that you're going to give me if you're trying to sell me this widget? And I think the important question to ask is, what are the problems that exist? So might it be common ones in a building? Might be lack of visualization. I've got a legacy system in there. And, you know, I can go to the plant room, have a look. I've got a 6-year-old system, a 7-year-old system. I can get access to it from the web. Okay, that's good. But I don't get all the data, and some of the sensors are dead and some of the things don't work, and I get a bit of info, but, you know, it's pretty basic. So I haven't got all the information at hand. Okay. What about the other problems? Well, sometimes we get pumps and chillers just stop for no reason, goes out on high pressure, or we get a problem for no apparent reason. We don't know why. Oh, so you're not doing predictive analytics? No. Well, the old stuff doesn't do it. And okay, what about a new provider? Well, if we go to our current traditional provider, big multinational, we can do all that, but it's going to cost me about $3 million to implement if I do all those things. Oh, gee, okay, well, that's going to give you about a 20-year payback. Well, that's not going to work. Okay. So you're getting faults, so you're getting more complaints. And the other problem we have is, well, in our building, we've got temperatures that are 5 degrees apart. In some parts of the building, it's freezing at 17 degrees or 18. In other parts, it's 23, 24 degrees. And we can't control it properly. Oh, gee, okay. So how can we control those problems? And by the way, our energy costs are going through the roof. Well, now with COVID-19, we've lost some tenants in the building, and we're left holding the bag. Rents are going down. We need to cut our costs. So how can we cut our costs? How can we survive? That's a big problem for us. What are we going to do? So there's some examples of some possible, use cases and problem statements that we need to overcome. So then we can answer those statements in whatever we're trying to deliver that says, well, we got this part that can help you save X, or reduce your maintenance bill by Y, or whatever. Reduce your energy consumption by X, saving Y. This is how we start to get to the business objectives of what is it they need? What's their pain? How can we solve their pain? And they're the questions that we need to establish. So I'm conscious of time, so that's all right. We're getting there. So what might a smart system look like? Well, whatever it is that you get, we'll be able to have access to all of this stuff, and management, building managers and building operators and smart city operators, councils, airports, rail, whatever, should be able to have access from any device anywhere, and be able to look, see what's going on, manage, change, make control changes from wherever they are. That's what a smart system might look like at a very high level, very, very high level. IoT protocols. So there's a number of them out there. And there's another discussion to be had on the pros and cons of each one. I'm not going to go into that, except to say my personal favorite, which we looked into a lot for collecting data in the built environment, is LoRaWAN. And we run our own private networks in buildings and places. We don't do public networks. If we want to get in a public space, we would work with the public operators in that space. So, but if you look at LoRaWAN, last year there was over 135 million end nodes all over the world. So it is the most popular IoT low power wide area network protocol currently. They forecast 200 million at the end of this year. Not sure with COVID where that will end up, but we'll find out. So it is most certainly deployed all over the place, and we're one of many happy vendors and integrators that use it very, very happily. And LoRaWAN standard, here it is, and it is wonderful. It's a spread spectrum. In our region, it's 915 to 923, now 928 megahertz. Asia, America, parts of the Middle East. But then we've got India and Europe that uses 868 megahertz. But yeah, it's an excellent protocol. It's got great cybersecurity aspects around it. Anyway, we'll have another discussion on that separately. And then, of course, machine learning, very important part, is a subset of AI. You can run a whole lot of algorithms and learn what's happening in a building or a place, learn its operation, and then slowly implement, smart ways to operate and save energy in using that. And then, of course, when you add AI, adds a new dimension where you can then automatically run and improve buildings and places and optimize all sorts of things using AI. And then, of course, fault detection and diagnostics. very fundamental by monitoring things like pressure differential, temperatures, pressures, monitoring water flows, energy, right through to power factor of every device, many different factors, vibration on motors, all sorts of things. We can get a real understanding as to what's happening in the whole ecosystem and get right into fault detection and diagnostics using both machine learning and then building AI and using AI to better determine when exactly is this going to fail. And I predict in 5 years' time, we should be able to, within the day, work out when it's going to fail from months ahead. But we're a long, long way from that. So quick case study. This is a case study in a system we had implemented in an office building using an IoT system from the cloud. And over 6 months, we can see, and this is comparing utility bills, 22-year-old infrastructure. What we can see in this case study, 64% saving on megajoules and 46% saving on total electricity bills in kilowatt hours year on year. This is Melbourne, so it gets a bit cold in wintertime. Not as cold as Europe, but it gets reasonably cold. So the numbers are very, very good. And there are many other things out there from many vendors around the world, both software, hardware, all sorts of things that can achieve all sorts of amazing outcomes when it comes to smart buildings, smart cities. There's so many wonderful things out there and technologies that when combined, whew, going to carbon net zero will not be a hard deal at all when we combine a lot of these great technologies. So I'm now ready to open the floor to questions and answers. So thank you very much for your time, and over to the audience.
Thank you, Bob. It was a great presentation, and it was a pleasure having you here at this forum. So I would like to ask the audience if they have any questions. Please feel free to unmute their microphones, or they can type in the chat window. So meanwhile, one quick question. What are the emerging trends in smart building and smart city domain during this pandemic period? I know things have changed quite abruptly. So what are you experiencing in this domain?
Well, at the moment, of course, people are mostly still working from home, even though companies are operating. Victoria has its own unique circumstances where many companies are shut, unfortunately. But in most cities, people are trying to work out how can we make our buildings safe, COVID safe, that is. So, we've got that question, but then we've got the bigger question of digital transformation in smart cities. So what people are now saying is, well, how can we do everything and save money? It's a bit like when we went to, when we had the GFC, many organizations were afraid of the cloud. They said, oh, look, it's unreliable, it's too hard, we'll keep everything on premises. But then the GFC came and that's it. After the GFC, companies migrated to the cloud like there's no tomorrow, because they found it was economical, it was reliable, and it worked really well. And I think we're going to find the same now, where organizations want to make their buildings COVID safe. So they'll want to know, maximum number of people in a building at any one time, for example. They want visibility of that. They'll also need it for compliance as well and auditing. They'll want to know in certain meeting rooms, okay, we're not going to overfill the room, so how many people are in a meeting room. They'll also want to know, are we mitigating risk of the transfer of viruses in buildings? So what about the airflow management and the number of air changes per hour, for example? Again, that can increase or mitigate the risk depending how many air changes you're doing per hour. There's many aspects of this around mitigation, and then there's sprays that you can apply to cooling coils, to filters, and even that the cleaners add on that lasts for 7 days, and it's actually, gets rid of COVID in 1 minute. There's a number of products out there around this. So I think there's now a move to make places much more COVID safe, but not only COVID safe, but it'll be a protection for future type events where if something comes, we'll be much more prepared and we won't have to lock everything down like we have this time, and we'll make it safer. But at the same time, we're going to reduce costs of operation, which is part of the whole deal in moving forward in the digital transformation of building operations and smart cities.
Okay, perfect. So what unique solutions Blue IoT is providing in this to make buildings safer? Like, do you have any adopted digitally transformed solutions in this pandemic?
Yes, so our Encompass Blue platform, which is not only building automation and energy management, and does save certainly a lot of money and carbon footprint, but we have the add-on around COVID. So where we do run people counters in all entrances, so we know how many people are in a building, and then we now can be able to measure proximity of people in areas that people want us to. So people don't, there's not too many people in a close area. And also, again, in the airflow management of our system, which already we do, and make sure we manage the number of air changes per hour. And then even going into thermal imaging of people coming in a building. So, big commercial cameras that can detect many people coming in at once, focus on the face and the head, pick up the temperature straight away. And if somebody's got a temperature, the alarms ring and we can deal with that. And then going into the antimicrobial sprays that are good for 12 months and TGA approved. So these ones that we use, for example, are used to clean up quarantine hotels in Sydney. So they're the sorts of things we're doing in managing and making the buildings more COVID safe, running the lighting systems, the HVAC and all those systems as part of the automation platform from the cloud, but with full visualization, alarms, analytics, and ongoing data interpretation by our domain experts. So it's quite a unique, not only disruptive technology in terms of the tech, but the client engagement model where we're continually there to support them in interpreting data, because people are being bombarded with data all over the place and they don't know what to do with it. So we use our domain experts to interpret, come back to the client, work with their mechanical contractors or electrical contractors, go out on site, fix, repair, get rid of energy waste, prevent outages and so forth. So works very well.
Okay, perfect. Any other questions from the audience? Well, if there are no questions, so I would like to thank Mr. Bob for his great presentation. We'll send you the recording shortly and we'll keep in touch. Thank you.
Thank you all for your time. Thank you.
Okay, bye-bye.
Bye-bye.